Hello there. So I'm Sam. Don't know why I'm here, really. I'm a musician. I'm come to talk to programmers. How many of you can program? Which is cool, right? Okay, so normally when I give a talk, most people don't put their hands up because I'm talking to children, typically, or teachers, or artists, or anybody else, really. And I think actually what I'm going to say for the next bit of time could possibly be useful for you as well, because how many of you have ever been to a party? That's pretty good. I'm quite excited. That's most of you, not all of you, I must say. How many of you tried to have a conversation about your work at the party? Yeah, right. How many times has that gone really well? Yeah, not. Or sometimes. Okay, were the parties programmer parties? Probably the answer is yes. And I think this is the problem, right? If you're a guitarist and you go to a party and people say, "What's your name?" You say, "I'm John the guitarist." And they say, "What do you play?" You say, "Obviously the guitar. I'm John the guitarist." They then will talk to you for quite a long time about guitars and about music, and they'll be able to find an interest. But when you say, "I'm John the programmer," or "I'm Kate the programmer," that often kills a conversation flat. And I think this is a problem for our society in general, because we need to find ways to actually engage more people in programming, not make it an opaque, hidden thing, but find out ways that we can actually engage a broader sense of society, and hopefully have that conversation where people are actually, "Cool, you're a programmer," and they actually want to talk to you. Right? And I think the biggest problem we have today is that programming is typically used for money-making companies. How many of you work for money-making companies? All of you. Right, okay. Now, that's not a bad thing necessarily, but it is a bad thing for programming, I think, because it's not very diverse. We're not using programming in as many areas as we possibly could. Now, you could obviously say the same for music. You could go to a music conference and say, "How many of you make music for adverts?" Probably quite a few musicians would put them hand up, because that's going to make them their bread and butter money. They're going to be able to afford to buy their children food. But a lot of musicians don't necessarily want to just make money for adverts or money for organizations or companies or lift music. You know, they want to make their own music. And so what would be the equivalent of making your own programs and making your own code that's going to actually be interesting and exciting to the world, that's beyond stuff for companies? And I really think that's really important to say that. And because if you go into a school and tell kids you need to learn to code because you can be a professional programmer, that's just a ludicrous starting point. It's like saying to kids, you need to learn to play sports, become a professional sports person. Because that's not why you learn sports. You learn sports because, why do you learn sports? Because it's good for your body, it's good for your well-being and your mind, it's good for teamwork. There's lots of positive attributes of sports that are not being a professional sports person. So why on earth do we have the same association with learning code and companies? It's a bit nuts. And I think that's the same problem for going into parties, because as soon as you say you're a programmer, you're basically saying, "I'd like to talk to you about business, business apps, or the scalability of this large-scale business. And I think that people don't want to talk about that so much. They much rather talk about music or culture or things that they're excited about that influence them. And I think that it's a tragedy that we haven't got a ton of things we can talk about immediately that come from programming. Because programming can influence society massively. It does already from a business perspective. But there's so much more we could do, that we could internally have good fun doing, but also could help us to engage a broader audience, a more diverse audience. Not just children, but everybody. And get everybody doing a bit of programming. Just like everybody does a bit of sports. Right? Not everyone's professional sports people, but everyone has a bit of a go, playing a bit of tennis or a bit of football. Does this make sense? Right? And I think it's really hard to get started, because if you say to people, someone says to you, like a kid might come up and say, "I want to learn how to make a game." You're like, "Cool, let's do it. What would you like to do?" And they're like, "Well," and their mind's whirring, like cogs are going, "I want to be on a horseback. I'm on a hill." And they've got Zelda in their head. "I'm looking over the landscape and I can see it in the distance as this castle. I'm going to go and raid it. And I want to actually I'm going to find all my soldiers and bring them together." And you say, "Well, I can do you a circle. That can be the castle. And we can have triangles." I mean, because obviously you're not going to be able to make a AAA game, you and a kid in a couple of afternoons. You can really limit yourself by doing something on processing or some very simple canvas drawing or something just to get started. Which, when we were kids, if you're all similar ages to me, would have been great. I loved moving shapes around a screen. It was brilliant. But people's expectations are drastically changed. So we have to find ways that are not just about programming, but are about things which actually impact people and they care about. And so I think there are many other things that, other than games, which can help this conversation. The first one is this thing called music. Yes, right, music. So what I want to do is I want to think about how do we actually find ways to engage kids and everybody else that's meaningful to them, but also how allows us to both answer some really deep and technical and interesting computer science problems, as well as get them excited about the basics of code. Can we do all of those things at the same time? Now, I hesitate to talk to people like yourselves because one of the first times I actually spent talking about music at a computer programmers industry-focused event like this was in the first Clojure Conj in the States. And I'd been working on the system called Overtone, which is a Clojure music system, with a friend called Jeff Rose. And we built this system. It was cool. We had been invited to go and give a talk at the Clojure Conj. I gave a talk. But beforehand, I was listening to these people talk about some event system they'd built in some, I don't know, banking thing. And they were talking about sending these events back and forth. And I was overhearing them. And I walked up and said, I recognize that problem. And they said, oh, what do you mean? And I suggested, well, in our system, we were doing this. And they said, oh, what's your system? And I said, oh, it's a music system. And they went, poof, and walked off. Right? So I think there's actually a problem also when as soon as I use words like music and arts, are people sort of trivializing what it is. But let me just put it in perspective. What I've written, what I'm going to show you is a soft, real-time, concurrent, deterministic, live coding with strong sense of time using sort of logical clocks system that kids can program, that you can program. Let me just put it in perspective. There's some really cool tech in here, and I'm very happy to spend as long time as you need to talk about it offline afterwards about any aspects that you want to talk about. But this is the system. It's entirely free. It's open source. You download it. You click on these buttons for Windows, Mac, Raspberry Pi, and Linux. If you have a Raspberry Pi, it's already installed by default. And when you download it, you get something like this, which is a text editor, and you type code in and it doesn't work because it doesn't make any sense. But this is the critical thing, because if you say to people, how do you get started, and they ask you, and you say, we're not going to do the game, let's do some music. The first thing you've got to say is, in download Emacs, or download IntelliJ, and Java, and Maven, and whatever, there's a lot of work, right? And most people are just going to stop at that. Certainly my mum is not going to install Maven, right? Is your mum going to install, because that'd be cool, I like to hang out with her if she wants to. And so the thing is, you've got to find out, and also teachers are not going to install Maven. So you've got to think about what is the simplest way to get started. So Sonic Pi, you just open it up, and you've got an editor all ready to go, and you can just type words in. And you can type words in, and you can press the run button, and it doesn't make any sense. So you obviously need to know what the first word to write is, and that's the word play. You choose that, and you get a beep. Very quiet beep, but I'm sure it'll get louder in a second. There we are. So this is your first program with Sonic Pi. It's very simple. You write the word play, you choose a number. You don't need to know what they mean at all. But numbers are pretty cool, aren't they? Who likes numbers? What do numbers do? Nobody knows. You're all programmers. You're all professional programmers. They go up and they go down. Do you not know that? Well, that's super useful. Remember that. The cool thing about the world is there's lots of other things which can go up and can go down, right? And if you've got a thing which can go up and go down, you can model it with numbers. You must know this. Come on, right? Lengths and distances and time and pitch are all things which you can model with numbers. And this is a way to get started with the kids. You talk about abstraction. You say, well, we've got this number. It can map onto things in the real world. What's a thing in the real world that you care about with music? How high or how low the note is. And so instantly, kids can start playing and writing their own tunes. And then you say, okay, let's play a melody. Let's play note 60, then note 65. And that might surprise some of you programmers out there. I don't know if you think this is an imperative language or a functional language or something in between. It's kind of declarative at this point, actually, because what we're describing is two notes to be played, and we're not talking about time. So although time is implicit in all programming languages, it's do instruction X, then do instruction Y for imperative. And this is kind of what's happening. If you notice on the right-hand side here, it's very small. Let's make that slightly larger. At time 0, we played both these notes concurrently at the same time. And sample accurately at the same time. So to 144,100th of a second, these are started at exactly the same time. So this is cool. We can do chords. And let's play like another one. Lovely. So we want to make a melody. We need one more command. Lovely. Who's enjoying that? Now, I don't know about you, but to me, this is the starting point for a beautiful conversation. Because if you think about it deeply, this is pretty much all of Western music. I mean, it's a broad claim, but it is most of it, right? What is Western music? It's which note to play and when to play it. You can make any melody by knowing which note to play and when to play it. Any bass line, any Tchaikovsky, any Daft Punk, right? And kids can do this too. And this shouldn't be a surprise. Like Logo had similar kind of properties. Logo, you have pen down, pen up, rotate, forwards. And with those commands, you can draw any picture, okay? With these two commands, you can make any melody. And kids do, and they'll go play and sleep, play, sleep, play, sleep. I had my 6-year-old niece. She was on line 100, and it's like, that's an amazing melody. Well, she's not finished yet. She was still going. And so this to me, this is really important, not to be able to just be able to do exciting, sophisticated things with programming languages, but to be able to do very simple things, and have the very simple things be approachable and simple. And all of you tonight can go home and do this. Now, I've got multiple goals in giving this talk. One of those goals is to try and get some of you to have a go at doing this tonight. Now, I say that because after the closure conference, I mean, although I had that negative conversation with those people and they were like, whatever, music, I got a standing ovation when I gave the talk. And Rich Hickey came and went, you're badass. And I was like, oh, that's amazing. And then all these people went away and downloaded it. And of course, they all had Maven and Emacs and all that sort of stuff. And so they could get Overtone and make music with it. Well, they couldn't because the starting point to Overtone was design your own synthesizer. And obviously nobody knows how to design synthesizers really. It's a whole set of skills. And so I remember walking to my room late at night, being really excited about the talk I'd given. And all these crazy sounds were coming from all the hotel rooms, which was great to hear, and I was really encouraging. But nobody got further than that because it was too hard to move on. So although these people were steeped in the technologies that I'd used, and so they could get started, they couldn't do anything more than make a horrible sound. So I'm hoping that I'm going to convince you that from here to being a professional DJ is not that hard and just a matter of practice. And we'll get there. So do you think you could DJ with this so far? No? But you could make any melody. That's already a good start. What else can you do, right? So this is cool because when you're teaching kids how to code, I don't think it's about what programming constructs are there and what languages there are. And it's about what do you want to do? And what of what you want to do can be achieved, right? And so at this point, you ask kids, what do you want to do? And they might say, well, that just sounds rubbish, that beep. And so then you say, okay, well, we've got different sounds. Let's play with different sounds. So let's change the synthesizer to D-saw. Or Prophet. Or piano. So we can play with all these different kind of these different sounds, which is a lot of fun. Now, each of these sounds, that might sound very simple, but down here in the documentation, each of these black things is a knob, right, a control. And if you think about them in terms of synthesizers, these kind of guys, so I go for one like this. When you buy one of these synthesizers, first of all, they're stupidly expensive and they're massive, so you can't really take them around very easily. So if you want to do a gig with one of these, it's like you've got to have a truck. But all these things here, because these are controls you can tweak and modify and play with, which is huge fun. And they will all modify the kind of sounds which are produced, which so you can sort of tune them into your own sounds. In Sonic Pi, each of these controls here is one of those knobs. Instead of physically turning an actual potentiometer, you just write the numbers you want to do in. And if you don't write any numbers, like here, there's no controls here, there's a bunch of defaults which get executed. So you just think of them as a hash map of key value pairs where the values are defaults, but you can override them arbitrarily, which is huge fun. So let's play that. So if I use synth Prophet, I can play note 60, or could even actually, if you know a bit about music, you can use actual music notation. I can change the release time to be 8. And one of the options in the Prophet is cutoff. MIDI note representing the highest frequencies allowed to be present in the sound. These are things you can explore. You don't need to know about them, but they're fun to play with. So what does cutoff do? Let's try cutoff of 70. You're already noticing implicitly is concurrency. The notes are overlapping each other, so every time it goes pink, I'm creating a new thread, That thread is running at the same time as everything else. Now, I don't know, how many of you done multi-threaded programming? How many of you would be prepared to take your multi-threaded programming on stage in front of thousands of people and perform with it? Right, that's how sure I am this actually is going to work pretty well. So you've got multi-threaded code running in the background, and we're able to play simultaneously. So this is actually one way to work with Sonic Pi, is you just have long-running things and just keep laying them on top of each other, which is huge fun. So I can start... It's just by changing around. So this might look crazy to you, but it makes a lot of sense to musicians. So I'm taking note E1 and going 7 semitones down. And this is the kind of cool thing you can do with this programming language called Ruby, which gets a lot of stick, but actually is a very flexible, powerful language for writing DSLs in, which is essentially what this is. So we're not caring about performance. This Ruby code is running at human time, right? So it's maybe spinning around maximum 32 times a second. All the audio synthesis is done in C, C++ by something called SuperCollider. And it's essentially what the Ruby code is doing is generating a set of asynchronous messages to be sent over the network to this SuperCollider server, which is then executing them on time. So my programming language just cares about what to do and when to do it. And it roughly does it around the right time and then sends it ahead of time to something which can then finally control and do it exactly at the right time. Right, so there we go. So this is fun. Where do we go next? So, well, let's think about this. There's another thing called sample, which so far I'm showing you sounds which are computed in real time from mathematics, essentially. So all those sounds, there are lots of lookup tables of square waves and saw waves and functions which take a number in and output a number depending on what the function does. So one could actually add a low-pass filter or a high-pass filter, so make it sound mellow or crunchy. These are just functions which take a stream of numbers in and spit out a stream of numbers out. But you could also take pre-recorded sounds. Does anyone know what a pre-recorded sound is? It's an interesting thing. It's one of those weird things. Like the airwaves obviously vibrate in and out, right? And that's what your ears hear. And so when I make a noise, like a clap, that forces the air to be compressed and decompressed, and those waves hit your eardrums. Obviously, if you were able to record those waves and note where the air pressure was, and wrote it down lots of times per second, and then use the same numbers to move something in and out in exactly the same way, that's how you can reproduce a sound. So the thing which records the airwaves is the microphone, and the thing which reproduces the airwaves is a speaker. And so a sample is really just a list of numbers about where the microphone was in time. And you just put that in a big file, and then you then send that to the sound card, and it's able to then send electronic signals to the speaker, which is able to then move it in and out the same way. So this sample is just a list of numbers, a list of floats. And you can create those things by recording them with the microphone, and there's a bunch of built-in ones. So let's look at loop Amen. It's just a pre-recorded sound of where the drums were. This is from the 60s, so we can go back in time with the sound, which is pretty cool. But the cool thing about numbers, right, and lists of numbers, is when you map a function over a list, right, you don't have to do that in one go. You can do it slowly, you can do it quickly. Obviously, you don't think about that when you're programming normally. You want it to go as fast as possible. But if you think about it in terms of music, you do care about the speed you go through things. Because if your computation is faster, you're going to get a faster rhythm. Right? If your competition is sort of in spurts and bursts, your rhythm's not going to be regular. And in this case, if I walk through those numbers at the normal rate, I hear the normal recording as it was recorded. If I walk through it at rate 0.5, it takes longer to get through the numbers, but it also has an effect on the sound, which is huge fun. And so you can obviously do this kind of thing. Or you can do something like this. What's that? Backwards, yeah, exactly. So you can walk through the list backwards. Half speed, right? So with Sonic Pi, you can take any, so these are the built-in samples, but you can record your own samples, you can download samples. They need to be WAV, A FLAC, OGG, OGG-A, or that's it. That's the supported ones. But yeah, pre-recorded sounds, and then you can start playing them back. So what about, there's a bunch of other stuff you can do. One of the funnest things to do is as a programmer, I see this, I can hear this as a sequence of drums being hit one after another, right? That's like an array of drum hit, which drum, and which time it was hit. Okay, but of course that's all encoded in this WAV file, this audio file. You haven't got this nice, when was each drum hit. But you can reverse engineer that. You can do some analysis. You can figure out when was the onset, when was it going from quiet to loud in the audio file, and then get those times. And so we have that built in. We just say onset 0, get the first drum, second drum. So we can pull all the drums out. So we can create a loop, stick for a short amount of time, and just repeat that same thing around, right? And then we can change it. This is fun, right? This is like a lot of 90s music in 4 lines of code. Now, I could spend ages picking apart this, and it's a lot of fun, but I haven't really got the time to. But there's a bunch of interesting tech, I think, which is going on here. First of all, we've got this weird thing called a live loop, right? That's a weird thing. That's a special Sam Aaron weird loop. And let me explain what I mean by that. So kids would do this straight away. Loop, do, sample, whatever, and be quiet, seat for 1, end, and they would like go. Like this thing going on, right? And they would have that, and they would say, right, I want to have that and some drums. Where are the drums? Now, how many of you are programmers? How many of you know why there aren't drums? Not all of you, that's unfortunate. So we have this problem of the fact that loops are infinite, and once the program gets into the loop, it never gets out, does it? It's like a black hole. They're rubbish, loops. I don't know why we ever use them. They're only useful if you're like listening on a network socket forever. When else are they useful? I don't really know. And so, yeah, the program obviously just gets in here and just stays there forever. So it never gets down here. So we have a problem. And this is, I know, this is, to me, was super exciting because, well, it actually was really depressing. Because the kids would say, well, why is it not playing at the same time? And you say, well, I know why. But unfortunately, I can't tell you the answer. Because you've got to wait till you're at university. Because it's not on the computer science curriculum. We can't cover this. I'm sorry, the teachers don't have any time for it. We can't do it. And the kids are like, want to swear in your face, obviously. But they're not allowed to because it's all very nice. And so this is a problem. And so we can't teach concurrency. We can't teach threads in schools. There is no time for it in the UK curriculum. And this is a problem because kids want to do this. They want to do this within a few hours of playing with this kind of system. They immediately want to be able to play the drums at the same time as the bass. That's what they want, drums and bass. Here we want choirs and bass. So the solution is to cheat. You create this thing called a live loop, which when you run it, it tells you need to have a unique name. Live loops need to have a unique name because these are now no longer loops. These are band members. And this is Petra, and this is Jane. Right, so you just give them names. They need to be unique. So in my band, I can't have 2 Freds. Not allowed. So it's a restriction. Otherwise, it gets confusing. And now we have both running at the same time. So we have concurrency with live loops, which is pretty fun, right? There's also an interesting thing about what's going on here, because concurrency is already pretty hard, isn't it, to get everything right? I mean, concurrency is easy, but actually coordinating state across threads, that's the tough bit. And then this has got another problem, because we don't care just about playing at the same time. We don't care about coordinating state, although this is not happening in this particular case, but we will do that later. What we also care about is them running at the same time, actually at the same time. Not at the same time, but on time with each other, like a band plays together. Like, there's no point having the bass guitar playing at the same time as a drummer if they're not playing at the same rhythm or the same tempo. Right? It's not good enough that they're both playing simultaneously. They have to be playing in time with each other. And if I were to change this to something shorter and play notes E3 or something with release time short, not very nice to listen to, but you can totally hear that's in time. And they really are properly in time, sampled accurately. So that's the other thing this live loop does, is it allows you to have not just concurrent things, but things in time. And then the third thing, which is the exciting bit, is that So what I'm doing here is I'm live coding. I'm modifying the code as it's running, and the threads just work. Timing is maintained. There's no pause or skips or anything. It just clicks in all the time on time. So live loops give you this ability to modify them as they're executing, which is a starting point for doing performances, which is huge fun, right? So this is where, as a programmer, when you go into schools and kids say, well, how do I do something? And the answer is you can't. Actually, as programmers, because it's such a magical skill we have, such an unbelievable skill we have, we can just go, well, screw that. I'm going to change the rules. I'm going to build something new. No, I'm not going to listen to that. I'm going to, okay, are we allowed to do loops? Yes. Well, I'm going to create a new kind of loop called a live loop. Is that okay? Fine. And that's it. The teachers don't know we're doing concurrency. They don't need to know. If they do, even better. But if they don't, that's fine. They don't need to know about live coding. They don't need to know that that's actually incredibly weird and difficult and not typical of programming languages, because kids have fun. And you can have fun, and your friends can have fun live coding. Is it making sense at all? No. Yes. Right, okay, right. So where do we go from here? So there's a few other things. Let's have a look at, what do you want me to do? Do you want me to spend more time talking about what you can do with this? Or do you want to ask questions? Or you've got me for a bit of time. Shall I just keep talking? Is this fun? Yes. Is it interesting? I've got no idea. I do it all the time every single day, so it's normal for me. But yeah, okay, let's think about other things. So I've got this thing called a keyboard. Has anyone heard of a keyboard before? It's not QWERTY, right? Kids want to play with this stuff. You plug it in, and you want to be able to look instantly when you plug it in. I've got these events coming in. So I've got this weird, immutable, event-driven, pattern matching, deterministic event queue inside Sonic Pi, which is, again, it's actually important to have all those things, because with music you care that the code always produces the same music. That's deterministic. And also I care that when I play a chord, all three notes, then I'm able to write functions which are able to ensure they're executed for each of the three notes. There's no race conditions about your function handler hasn't been created quickly enough for you then to be able to observe that event and then do something on the basis of it. So it's important to be able to store the entire history of all the events so that you can even play it back and you can mess around with it and treat it like a data structure. So here we are. I've got some keys. I know I'm connected, which is pretty fun. What can I do with it? So I could create a live loop, call it foo. I can synchronize on, and here are all the different things I can synchronize. So all the live loops themselves, I can synchronize them. So you can synchronize between live loops, which is really important. But also I can synchronize all these MIDI events. So I've got this note on MIDI event. So I'm going to wait for that, and then I'm going to play sample, bass drum, boom. Notice there's a delay. Can you hear that delay? Yeah. Half a second delay. Now, that's because this system schedules everything ahead of time. Right? The fact I'm using this weird language called Ruby, which has got a garbage collection, which is nuts, right, for a soft real-time system. At any points, the program can say, pause, I'm going to do some cleaning. Like, you don't want it to do that when you're making music. Like, no to the garbage collector. And all sorts of random stuff can happen. So by executing the code sufficiently ahead of time, and then making sure that something else doesn't have a garbage collector, which is supercloud in this case, we're able to schedule things ahead of time and have them work. But of course, in this case, because I'm getting an event in and then sending it ahead of time, that's adding a latency. That's a problem. And so how do we fix that? Well, we can just turn the latency off for each independent thread by saying use real time. So this thread now no longer schedules things ahead of time. So now I've got my kick drum. But of course, this data structure coming in has this pattern here. It's like a URL, MIDI. This is the name of the keyboard. This is some MIDI nonsense. This is the note on, note off events. And this is the note, and this is the velocities. So at the moment, my keys are doing the same thing, but I can get the notes and the velocity and extract those. Instead of playing that, I can play note N. Here we are. So now I've got a keyboard. Make it short release. So if you want that with maybe some reverb, you use this cool thing called a anonymous function. So Ruby has this really cool property where I can say do end, at the end of any method, and it creates me an anonymous function, which then again, in my method, I can execute whenever I want. And Rubyists tend to use this to essentially set up and tear down contexts before running arbitrary functions. So in this case, I want to add some reverb. So what does that mean? Well, in a guitar, I might get a guitar and plug into a reverb pedal, plug it into a distortion pedal, plug it into my amplifier. So here, I need to go and magically run to the guitar shop, buy my reverb pedal, great, got it, and then plug it into my amplifier, and then make sure that any other synthesizers which are created get plugged into the reverb on the fly. And that's what happens here. So now we can play, run the code. And then maybe I want with echo as well. So it's very easy to add effects and chain them, right? And if you're of the how would I say, very positive inkling of being a Lisp programmer, which is a good thing, you'll make complete sense of this, because in Lisp everything goes from the inside out, and here we're going from the inside out. So our play goes through echo, goes through reverb, and then goes to the outside context, which is your speakers. So this way we can arbitrarily nest all these effects, and now we have the ability to play notes. Does that make sense? Is that fun? And you can do the inverse. I haven't brought all my kit, but you can plug in external synthesizers, so external MIDI-driven synthesizers. And we have a really nice Erlang scheduler which does all the scheduling for us, which Joe Armstrong wrote, of all people. So that allows you to bypass all the garbage collection nonsense and pausing of Ruby and be able to schedule things ahead of time and have them get sent out on time. You could also do something like this, live audio. Give it a name. And if you have that plugged, if you have a guitar plugged into your audio card, then you would be hearing the guitar, right? And you do the same kind of stuff. You can add it with reverb or distortion, and so you can add effect to any external instruments. You can have a microphone be plugged in and have someone sing. And with that one line of code, you've got a clean signal. But then with some effects around, if you say live audio voice, give it at least have a unique name, and then you have like a reverb. This now would, if I turn it on without, obviously with my computer having the microphone attached to it, listening to the audio, it has feedback. But yeah, this would give you a voice with reverb. It's a lot of fun. Now, I don't know how long I've got left, maybe 10 minutes or so. It's important to point out that everything I'm showing you here, although it might be weird and new and novel and, I don't know, confusing perhaps to some people, I can teach you a 10-year-old child. That's a really important thing. Every single feature I put into Sonic Pi, I've had to ask myself, could I imagine teaching this to a 10-year-old child? Which has been the most insanely difficult filter to put features past. There's lots of really exciting music systems in the world out there today with lots of really exciting music features that are just, for me, so far, too complicated to consider how I might put it into this kind of program that's simple enough for a 10-year-old child. But it turns out that when I can do that, I end up with a system that actually really works really well for a very tired Sam, 2 in the morning, who's had a couple of pints, who's about to perform to, I don't know, a bunch of people in Munich, which is what happened last Saturday. And so, actually, a system which is simple enough for school children in the classroom turns out to be simple enough for you to be performing with it. It hasn't got such a cognitive load. It doesn't require you to really think so deeply about the programming process. It just allows you to think more freely about the musical outputs and the musical contexts. And then maybe there's a bunch of things to extract from this talk from your perspectives, but yeah, I mean, obviously we can talk a long time about time and live coding, but really about making the language simple. And not just simple to write, but simple to think about, simple to reason about. Actually really helps you get to the core of the business logic you're trying to write. In my case, the business logic is music, but it could be anything, really. It could be your money-making businesses, banks and whatever. Lovely. Okay, right, so let's think about what else we can do. We've got 10 minutes, let's have a play. So we've got ability to receive events, we've got ability to send events, we've got ability to make sounds. That's all we need to make music. So let's think about it. So if we create a live loop, let's call it foo. I can, let's think about what we could do. Let's get the note and velocity, let's get it from our keyboard, this one. And then let's, I don't know, 8 times. Let's play notes. and have a release time short, and then sleep for a short amount of time. So now I've got the ability to just have the computer play the notes for me, and I'm just choosing which note to play, so I'm not having to worry about timing at this point. But you can do fun things, so like I can use synth D-saw, and then I can have the, what options have we got on here? We've got DK, D-tune's a fun one, D-tune, 12. Or I can say is a scale minor, pentatonic, tick. Now the trick is, right, I've got my arpeggiator going, which is quite fun, right? So I've got essentially two saw waves, one playing note N and one playing note N plus a minor pentatonic scale. This parentheses around is good because we like Lisp and we don't want people to be scared about Lisps. And Lisps have fewer parentheses than Java. This is really important to recognize. This is an immutable data structure because scales are immutable. They're always going to be there in time. They're a mathematical declarative description. And here we're ticking through them. This is a really weird construct which uses thread locals because we haven't got state on our immutable data structures. But don't worry about that too much. All you think about is we're treating this like an arpeggio going round and round and round it. And we're playing this thing. So the question now is, how do we get the drums in? Right, we can easily do that with threads. We can add another thread, which has got the kick drum going. But how do we make the drum be in time? Right, because I know how to start a new thread, thread.new. We'll create a new thread, right? But how do we get a new thread to work at the same time? Well, we can try our best and create a live loop called bar and sample bass drum house, seat 4. That's okay, we can hear it's offset, right? So what we can do is we can stop all the music. This works really well, right? That's a good idea. So one thing we do know for a fact that our system, this system, does start every thread with the right logical time. So you could stop everything and start everything, but that's not going to work in a performance, is it, right? So let's try and do this again. Let's uncomment this. So what we want is we want a way to say synchronize with another live loop. So this live loop's called foo, so we just synchronize with foo. Off we go. And so this is a critical aspect of the system, is that this is kind of like a closure promise or a blocking construct which will block the current thread until an event happens. In this case, the event is this foo live loop goes round. And so once it's gone round, this can start, but it also shares across the thread boundaries the actual logical time. So when this thread starts, it has inherited the timing mechanisms of this thread, so they are in exactly the same time. They have the same clock. And so that way, you have concurrency, but you also allow the threads to actually work together in time with each other, which is huge fun. So let's get that going. And then you get another live loop, bar, and let's bring in some samples, foo pop, grooves, beat stretch it, C for 8. Oh, I've got the 2 bars. Baz. Off we go, right? So we're able to bring these things in and out. That's just a sample. Oh, it's been turned down. Okay. Yeah, that's more like here. And this, I'm trying to get to the point where we're actually starting to make something which might sound a bit like music. Hopefully you can start to see that. And this is just 22 lines of code, quite a lot of white space. We've got one live loop making the drums, one live loop playing some samples that are being pre-recorded, we're doing some cool things. We're pattern matching over the samples, so we might have a whole directory of samples, a whole directory of directories of samples. Musicians will have gigabytes and gigabytes of samples. And so I'm able to search through them by doing string matches on the file names, regular expressions on the file names, or even lambda functions on a set of candidate file names. So you really are able to then filter these things out. So in this case, I'm finding all of the E-bit bass samples. This is just a directory of samples which contain the string 120 because that's the BPM. They contain the string C minor because all my samples are well named. Choosing the first one and amplifying it by 3, and then doing the same thing but with a drum sample. And I can even start to mess around with this. Do this kind of nonsense. Another rhythm out of this groove sample by using iteration and randomization, which is actually a really important point. So I haven't really spoken about it at all, but I can talk about it at great length. That randomization is actually a really useful tool if it's not random, right? Randomization is really useful if you're doing crypto, right? And then you care about entropy and you care about it really being properly random, right? And so then you'll take pictures of lava lamps on a big row, right? But when you're making music, it's quite nice to be able to say, find me some random notes. But it's not that useful if you liked those notes. Because you say, well, I'd like them again. Sorry, they were random. And maybe you could find them again in 10 universes of time, right, if you were lucky enough to get exactly the same results from the random stream, but it's unlikely. And so actually what tends to be really useful is just to say, give me something which sounds random, but if I like it, I'd like to be able to reproduce it. And so this construct here is a really nice way of doing exactly that, because I can let's just comment these out. I'm choosing a random onset 7 times and then resetting the seed so that it will choose me the same ones. And if I don't like this, I just change the seed. Obviously, I can use any sample, so I can just change the sample. It's going to find the onsets in that sample, so I can completely change it around, which is huge fun. Again, it's a very simple thing to do. So this R pitch is able to know that, it's like weird maths, right? If you get a frequency and double it, that's an octave, always. So any frequency, double it, that's an octave. But then pitches on the piano, these sort of white and black notes, it's not really clear about which notes they are. You know that one C to the other C is double the frequency, but depending on which culture you're from, which notes you have at your disposal, and how you actually decide what frequencies are is completely arbitrary. Currently in our weird Western philosophy, we've decided that we have 12 notes in between an octave, and we take an octave and divide it equidistant across those 12 notes. And so this is able to then figure out what the actual pitch offset to rate modification to this sample to make it go up the right number of semitones using some crazy maths. But again, this is the kind of thing that if you think about as a programmer, you can go and read the material, read the resources, read the theory, and then figure out how to make it really simple for people to use. So again, I don't want to have to think about roots of the power 12, right, when I'm programming in a nightclub, but I do want to care about adding 1 or 2 or 3. That's the easy thing to think about, right? So that makes a lot of sense. Cool. So this is making sense? Are you enjoying this at all? Yeah. Do you think you might want to play with this? Yeah. I hope you do. There's a few things I want to finish off with. First of all, is when you download it, where are we? Here. There we are. You get an app like this. You actually end up with editor in non-pro icons. So they look like this, so the kids can read what's going on, run, start, play. I always go for the pro icons to look a bit slicker. And then if you're playing in a nightclub, go for the dark mode. That's always good. And you can turn the scopes on and off. Like you can move these things around, put it over there if you want to, or up here, depending on what you're doing. And then, is it going to crash? No, it's not. And then, oh, I should have plugged my computer in because it's going to die in a second. Whilst I do that, you could also then ask how do you start. So, that's unplugged and plugged in. And you click on the help button. Well, that's the information button. And here we have, down here, tutorial. And you can get this whole tutorial thing, you can bring it out.
Can you show the bottom section?
Down here? Bottom section of what, sorry?
No, the one where it says tutorial examples, I don't have that one.
So you haven't got this?
No, I don't see that.
So I just clicked on the help button up here. Oh, it's full screen. And that just makes that appear. And you've got tutorial examples. Maybe your app's like bigger than your window. If you double click on the title bar thing, you double click on this guy, maybe then it'll stretch it to the right place. If not, I'll come and find you later. The tutorial's there, and it's basically a full book. It's like over 35,000 words. It'll teach you everything you want to know about programming. If you know that already, then you're going to be flying through that. But it'll also teach you everything you need to know about the music required to make music with Sonic Pi. So it'll teach you both. If you know a little bit about either, you'll fly through. If you know nothing about either, you should be fine. And this is my promise to people who are reading this, it's a promise to you and a promise to your friends. If there's, like, on section A8 or section A9, there was a thing you didn't quite understand, that's my fault, not your fault. Right? And I'll do my best to fix that. So if you do find aspects of the tutorial which don't make sense, please tell me, and I'll apologize, and I'll do my best to fix it for the next person. It's too late for you, but for the next person, I shall be able to help. So again, and I really hope that most of the tutorial is really, really simple to understand, so you can learn it that way. And then there's these examples. You can just choose an example. Like, one of my favorites is re-resed. Cut and paste that up here. Run it. We've got a track, right? Off it goes. Coded music, right? You don't need to worry about... and this is the thing about the randomization system, right? You heard that melody. Same melody, right? But how is it being generated? Well, we're shuffling a vector of numbers, but we're shuffling it the same way every single time. So the determinism actually is really useful, because if I send you this code and your system does a different randomization order than my system, we're going to hear a different melody. And I'm about to be like, this is a banging track. You go, this is rubbish. Right? Just purely because the randomization systems made different choices. And so what I tend to do is I tend to shuffle things, but change the seed until I like it. And that's a great way of exploring the kinds of melodies you can choose. In this case, the first one was actually quite nice. Don't need to set the seed at all. And all I'm doing, shuffling it and ticking through the notes 64 times and adding some effects. I'm doing some crazy things like this, sleeping for -t. That might be exciting to some programmers, going backwards in time, which you can do because you're scheduling everything ahead of time. So within a buffer, you can go backwards and forwards in that. And there's a function called time warp, which will let you take any arbitrary piece of code and push it forward or backwards in time, and it will execute at a different point in time. Playing our sample and playing our bass drum, simple as that. And so we can just take something like this, change the rate of this, change the effects, crush. This is a low pass filter. And when I press ping, change the sound, right? Just change the effects and brought the sample back into the normal rate. And this is the kind of thing I will play in a nightclub, and people go crazy for it. It's a lot of fun. And watching the audience and changing what you do based on whether they're liking it or not, you can totally do. And you can improvise the music on the fly, which is a lot of fun. And it's great to be able to then to tell people, write comments. Can I have another beer, please? That's a good one to ask. Other ones is like, who thought programming could make music? And people don't know that. And who thinks programming is just for business? Most people. And I think it's our job to actually not just make money for business, because that is an important thing for some people in this world. And I'm vegetarian, and lots of people eat meat. That's totally fine, right? I'm not going to preach to you. But also, I think that it's an opportunity for us to think about how can we use our skills to make the world a better place. And if your organization, your company is doing that, yes, right? But if it isn't, think about what else you could do, right? Where else could you go? What would be your Sonic Pi that you could write? Because I'm sure most of you got much better skills than me. I'm just very patient and just sit there for a long time waiting for it to work, keeping on at it like this. It's going to work, it's going to work. Writing Windows installers is exactly that kind of nonsense. But it really, honestly, it's just a matter of patience. So what could you write that could actually make the world a better place? That isn't just about making large organizations richer and the stakeholders and that richer still. And so they have their fancy islands. But we're struggling to try and figure out how to go forwards. And on that note, the biggest problem I have, which maybe some of you might be able to help me with, is funding. So I've been luckily funded by the Raspberry Pi Foundation for the last 5 years, but they've decided to move on. I mean, I'm very lucky to have had that funding so far, but I'm stuck now. And so if I want to keep this software free, which I want to, right, because amazing things can happen. Finland sent a bus to Africa and taught 2,000 students, predominantly women, how to code using Sonic Pi. And that was a beautiful thing to see. And I went and met 12 other delegates from 12 different countries in Africa who all are giving me high fives and hugs. And that wouldn't have happened if the software cost money. It's because it's free, people are able to take it and do amazing things with it. The problem is that for some reason, because we live in a world where companies are making lots of money from products which are expensive, we don't seem to, in our society at least, value free things. How is that? How is it we don't value free things which are free to reproduce? Like, it doesn't make any sense. To me, those things should be the most valuable things. Like, it's an amazing thing to be able to have something that you should just give freely to everybody if people can freely use. Yet somehow, societal-wise, we don't value that at all. So it's incredibly hard for me to continue doing that. So I'm trying to raise money. So if anyone has an organization that's looking to spend money positively, especially when we're talking about impact and diversity and teaching children and adults and everybody how to code, then this is an interesting place to potentially consider using your funds. But also, if you're individual developers, then there's this Patreon thing, which I would really recommend you considering giving me some donations for. I'll get $1,000 a month, which is brilliant. But is that enough for a salary? Right, that's the question, right? So if you think about what you earn individually, it's going to be a lot more than what I earn, for starters. And I'm not asking for that much. So figuring out how do we actually get people like myself, and I think there's lots of interesting people who could really benefit from being able to use their skills to make the world a better place. And figure out, Patreon maybe is one answer, it's part of the answer possibly, but it's not the whole answer. But ways for us to share our wealth in a way that allow people to have the joys of this, but with code, right? And all the other aspects we can take code to as well. So that's really the general gist of what I'm trying to say. Does it make sense? Is it interesting? I've got no idea. I don't know. Am I running out of time? I think I probably am. We have 5 minutes left. I think probably questions is a good point at this point. Any questions? Or have I bored you all to silence? Yes?
Are there any interface points with other digital audio workstations?
Are there any interface points? So yes, the major interface point with things like this is MIDI. Yeah. And Sonic Pi supports MIDI out, very well timed through the Erlang scheduler. So you can send MIDI on all channels. We have a whole, if I type in MIDI, there's all the different MIDI functionalities, MIDI channels off, local pressures, all that stuff's all there. So you could send any of the MIDI messages to any of the things. And by default, MIDI will send to all devices connected, but you can send it on channel basis or whatever basis you want. So yes. And then there's also something called open sound control, which MIDI goes via the... MIDI is a weird thing. It's like it predates most operating systems, all operating systems pretty much. And so it's there. It's one of the few things where you can actually connect a device and have Chrome talk to it because it's in the operating system. But this thing called, but it has limitations. So it has 7 bits for data. So you have 127 different value points for a potentiometer, which is not enough. So you can hear that unless you smooth over it. And so you want something with a bit more than 127 different data points. It's like 32 bits would be a bit better than 7 bits. Or 64 bits is ridiculous amounts. So there's a thing called open sound control, which lets you send float values over the network. And we support that as well. So if you want to talk to other programs, get data in and out between Sonic Pi and processing or other visualization systems, open sound control is a good solution as well. Yeah, and both of those run through the Erlang scheduler, so they're extremely well timed, and they work with all the timing system built in. So all the synchronization stuff just works. Yes?
Can you export
Yes, so there's that weird circle at the top. That's your record button. And if I press that, it's now recording. Play 70. Recorded my note, press record again. Ask me to save it as a WAV file. So I can save anything as a WAV file. This actually, although you might think that's exciting, I think this is rubbish. I'm much more excited about the stuff we haven't done yet, which is to be able to export this as a data structure of all the events with a time basis, such that you don't have to have a WAV file. You can just have a list of all the events that happened and play that back. And that will happen soon. Yes, I'm almost there. But yes, you can certainly record it like this. And you can also record multiple channels and send multiple channels out if you've got multiple a sound card with a fancy setup as well. More questions? Yeah?
Were the live loops actually a reaction to not being able to teach the kids concurrency?
Yes.
Really, they wouldn't let you, and so you had to get around.
Yeah, I mean, so first thing I introduced was a notion of a thread, and I called it in thread because I wanted to be able to hit the stop button and kill all the audio. And in Ruby, if you create threads, then they just get created, and you have no handle to them unless you manage the handles. So I handle the whole ancestry of all the threads which are created from the DSL. So when I hit stop, I can traverse that tree and kill them all. And then I wanted to be able to modify the code live, and it was just, I had it in thread, and I had a function, and I was doing them both at the same time. It just seemed too complex to teach to a 10-year-old child. So this is an example where I was able to technically do something, but I wasn't able to express it to a 10-year-old child. So then I modify the syntax such that I could do both. And that's what live loop is. Yeah. Yep.
Can multiple people play over a network?
That's a good question. Can multiple people play over a network? So yes, now with the open sound control stuff, you have to do a bit of your plumbing yourself. So you have to send OSC messages so you can send like use OSC. You say where you like it to go to and which port you would like it to go to. Then you can say OSC foo. Is that going to me? Which port am I listening to? 4557, is it? Oh, I can't remember. It listens on a port. Oh, maybe I've turned it off as well, actually. But yeah, this will just hopefully get a loop back. But you can send messages to any arbitrary machine and port number, and you can also receive them as well. They appear like the MIDI events down here. So all the external events come through the same system, which you can pattern match and time on. So that's one way of doing it. But I am working on the ability to do live jamming together so that we can sit in different cities and be playing music at the same time. And having the deterministic part of the system there allows me to be quite confident that we're going to be hearing the same things, which I think is quite unusual for these kind of systems. Yeah, any more questions? No more questions? So who thinks they might download it tonight? Fabulous. And please play with it. And more importantly, who thinks they might share it with their friends? Who's got friends? Right, good. Please share it with their friends, because programming is not just for programmers, it's not just for business, it's for everybody to some extent, just like sports is for everybody. And we should really try to use our skills to share that joy with others as much as we possibly can, because then we'll be able to go to parties and have conversations about programming. And that would be great. Thank you very much.